Hello and welcome once again to episode 894 of Code Completion. We are a group of iOS developers and educators hoping to share what we love most about development, Apple technology, and completing your code. My name is Dimitri and I'll be your host once again for this episode, and I'm joined today by my fellow completionist, Spencer.
Hey there.
So word on the grapevine is that you started using actors.
Oh, yes. Started as in I've used a single custom actor, but yes, I did. I did start using them, and it was an interesting, I don't know, I spent maybe 45 minutes to an hour just kind of researching them a little bit. So what I guess I was trying to do was, I was working on a Vapor app where I basically, I don't even know if this is the right solution, but what I Googled came up with an actor, and so I was like, I'll try it. Cool. Let me pull it up so I can remember exactly what it was that I was doing. I think the biggest thing, the biggest thing was I was trying to make it so that I think I didn't need this for what I was trying to do, but I was looping through a bunch of items that I needed to do some concurrent work on, and I basically just wanted to stop the next one from happening until the last one was done. And so I think I was using an actor. I've got a couple things in the actor, but I think the biggest thing was that I basically just had a Boolean to act as a lock to say whether the next one could go or not. But I think my interesting thing with that was everything, all of these interactions with the actor, I had to await everything, which makes sense because only one thing can access whatever the resources at a time. And so I thought that was interesting. I made a comment that I was like awaiting everything. And another interesting thing that it makes sense now that I've done it, but it was weird that I had to, for example, make my own function to set the value. At least that's what it seemed like to me, where I couldn't do it. It gave me an error. I can't remember what the error was, but like trying to do something in a non-concurrent or in a concurrent context. I don't know. Anyway, in a different context. And so I just made a function that was like set this Boolean. It was a one-liner, but it had to be within the actor itself. And then I awaited that for it to actually set the value. It was interesting. I think the closest thing that I can compare it to is when we would like make a cache at Lambda School, and we'd have our own internal dispatch queue for that, and it would kind of do it would just dispatch sync everything and make sure that it was all hunky-dory concurrency wise. So if that's similar to what it's doing, and I'm sure Dimitri will get into that, it's nice that you pretty much just put actor instead of class or struct, and it basically handles all of that, kind of the background workings of concurrency for you. So yeah, that was a little rambling, but that has been my about 1 hour of experience with actors so far.
That's interesting that you couldn't modify the property directly. Like I have to admit, my own experience is sparse at best. Like especially touching every aspect of the Swift language from a concurrency point of view. Like I think you should be able to say await actor.property equals something.
Maybe
like
I just didn't await it. Yeah, maybe it was just that I didn't await it, and that was the problem. Anyway. But the concept of actors is cool, I think, so.
Mm-hmm. Yeah, they definitely make it very easy to have shared mutable state. And if that's a bunch of gobbledygook words in your head, that basically means that multiple things can access an actor at the same time, and the actor will make sure that only one actually has access until it finishes, and then the next one can have access. So you don't end up in a situation where everything is reading a value at the same time and then modifying that value, potentially doing stuff simultaneously that shouldn't be done simultaneously. So you can go ahead and guard certain access patterns very effectively. For example, if you wanted to toggle a Boolean, you don't need to, in the code, in like your calling code, you don't need to go ahead and read the Boolean, and then if it's true, make it false. If it's false, make it true. If you did that across 3 different things all at the same time, who knows what's going to happen? It's not necessarily going to go from false to true to false to true. it's going to potentially do all sorts of different things because the time that Boolean is read might be different than the time that it is written to. And that's the key piece to keep in mind. So actors make sure that you have a mechanism where you can have a single function called toggle, for instance, that would make it so that way all the callers can toggle the value and potentially get back what it was at that point in time. But the end state of the actor is going to be consistent no matter how many things access it at once, as if things were accessing it one at a time. So it's a pretty significant departure from what computers used to be like as soon as like 10 years ago. Like it really was very recent that we had computers with multiple processors as the norm, right? That can have access to memory at the same time. And it really was, before that, just cheating. Just as like saying, oh yeah, multiple things have access to this, but not really. It was just like one CPU that was just intermixing multiple threads and saying, okay, you get a chance to do something now. Okay, you pause. Now you get a chance to do something. And that was how things went. And therefore, I would say as like a whole, developers everywhere were kind of unprepared for like a true multitasking. And like true to us as humans, like we fail at multitasking, and therefore we fail at communicating multitasking to computer as well. So this hopefully gives us some good a good repertoire of things that we can use to communicate what we want without running into the gotchas that are like everywhere, right?
Yeah, for sure. And maybe one of the, I don't know if this is necessarily one of the gotchas, but what you were saying earlier made me think. I remember I had a student, I think, at the first boot camp I worked at, where we used, for a little bit, we used Firebase as sort of like a backend whenever they wanted to, have any server-side information, off-device information, and then we moved to CloudKit later, but I think with either of those, he probably would have run into the issue where I think he wanted to have like a social network type of thing where you could like post something and then see the amount of views that were on, a post, let's say. Can't exactly remember what it was, but I think one of the issues was him trying to figure out how to increment the view counter well, because it was on the server. And so, if it was like 12,000 views and then you say +1, but you've got a bunch of things doing that at the same time, then you'd end up with 12,001 instead of like 12,005, right? So
yeah, that's the ultimate concurrent like operation, right? You have two different computers, one on the server and then many on the devices, and they're all trying to say, hey, the view count is higher because more people are currently viewing, right? Yeah.
So with this that I'm doing right now with Vapor, it's an actor, and I've deployed it, so I know that it's like actors work already with server-side Swift, but like just non Apple device code, like it's open source, I guess. I don't know. It's a part of the language, right? It's not a part of like Foundation or anything. So as far as I know, right?
Yeah, and I think that's a big departure as well from other server-side technologies. Like if you wanted to run a server with Python or Node, what you actually end up having is multiple instances of that server running. Like oftentimes you have as many as one per core of the machine. And those instances are different programs. They do not communicate with each other, and therefore you have no shared state that you can rely on at any point in time. So one significant difference between Swift and those different frameworks is Swift based servers tend to be one process that is running, and every core instead gets a run loop that is processing events like simultaneously but not independently, and that's what allows you to have shared state really easily without running a completely different process like Redis that can go ahead and act as that shared mutable state on your behalf. But then you have to deal with crossing process boundaries and having all sorts of inefficiencies there. So that's like a really cool thing that Swift is enabling in the server world that most people just don't consider unless you're writing a server in C++. That is available to you and really simple to use. Like as you probably like saw, all you have to do is sprinkle await everywhere. But as long as your calling context is await, is async, then you're good, right? Like we're really hoping. Like I don't know if everyone's hoping for this, but I kind of find myself hoping that the app development scene is going to get that littering of async and awaits at every point that code can be called from. Because at that point, you can go ahead and have a lot of fun doing stuff without even thinking about like concurrency for the most part, especially like if a button is pressed, what's going to happen? And so on and so forth. Like Swift UI makes that a little bit easy with .task, like on the view itself. But I can see that going much further. And it kind of falls apart, of course, with UIKit and delegate callbacks and all that. And that kind of brings me into one of the first gotchas of the new Swift concurrency system, especially when we're so used to GCD like being a queue-based system where you can have serial queues and you can schedule things. A lot of people might assume, hey, actors are kind of a queue. It's shared mutable state. It's just like you were saying, Spencer, where you have dispatch queue async whenever you're accessing stuff, and you're doing that on a queue, and that queue does things in order and everything's good, right? Well, it turns out that's not true at all. Like actors and tasks have no guarantees whatsoever. In fact, they actively discourage you from thinking about them this way, that things are going to run in the same order that you dispatch them. And that is a huge gotcha with Swift concurrency, is that there are no serial queues that are given to you out of the box.
Yeah, I agree. I don't know. It's been interesting with the stuff that I've been doing with Vapor, where I don't know. It's been a little bit of a learning curve to learn async await, although it's been ultimately fantastic. But some of the things that I've been doing are like, writing a for loop to either fetch or save a bunch of stuff, and that for loop, like you're saying, there's no guarantee that it's going to be, I guess, any of those are going to be processed in the same order that you start them on. But then you've got like task groups that I think kind of facilitate that a little bit.
I think you have it the opposite. So task groups will run everything all at once, whereas if you have a for wait, that will wait until the previous task is finished before starting the next one. If that makes sense.
Yes, it does. Although what I've been doing is like not for awaiting, but just doing a normal for loop, and then within the loop I've been awaiting. But maybe that doesn't make a difference.
That's basically the same thing.
Okay.
Yeah. So. Let's step back a tiny bit. So it all comes down to when a task is dispatched, and what I mean by that is when you make a parent task. So when you say task, open curly brace, you do stuff, and then end curly brace, the execution of code just continues. It doesn't run that task right away. It just schedules it to be run, which it might run right away on a different thread, but it's not stopping your current execution. You're not suspending at that point, right?
Right. That's like .async.
Yeah. And if you have multiple tasks, so you make one task, you do stuff, you close the curly brace, you make another task, you do stuff, you close the curly brace, you make a third task, you do stuff, you close the curly brace. There's no guarantee that task 1 is going to run before task 2, which is going to run before task 3. They can run in any order. In fact, task 3 might be the first one that starts off. And this is to prevent an issue called priority inversion, which has plagued GCD. Whenever you want to try to get fancy, saying, oh, this is a user task, therefore it should run faster, and then you suddenly shot yourself in the foot. So that is impossible with the Swift concurrency system, because if you say that this task is a user task, and it depends on a much lower priority task, it's just going to run the lower priority task because it's a dependency for the higher priority one. So it's just going to go ahead and do that, and not wait around for you to put things in the right order that they need to be. However, something that we're tremendously used to with GCD is having a serial queue and then asyncing to it 3 times and expecting that although we're not going to stop right now, we're still going to expect that those 3 things are going to happen in the order that we called them, right? Like you're going to expect the first one to finish before the second one starts because it's all going to the same queue. But there's no concept of queues, so therefore that whole mentality falls apart. So there are a few ways of dealing with this, and I kind of hinted at one of them, and that's to make a dependency. So for instance, say you have your first task, right? Task actually returns a handler, and that handler can be canceled, or you can await it to get the value out of it, and that value is whatever's returned, and therefore you guarantee that the task is finished before you get a value out of it. And the neat thing that you can do with this is you say let task 1 equals task open curly brace do some stuff, okay? Even if you're not returning anything, that task will still have a value that can return void, basically nothing, but you can await it. So you can say await task 1 dot value, and that will wait for that value to be processed before continuing. Of course, you can only call this in a concurrent context, which is the error that Swift Concurrency always throws around at you. It's like you're trying to use this method and it's not available in a non-concurrent context. So what you can do now is say let task 2 equals task open curly brace, await task 1 dot value, and then start the stuff in task 2. And then close your curly brace. Let task 3 equals task open curly brace, await task 2 dot value, do stuff for task 3, and then close that curly brace. Now, it doesn't matter which one starts first. Say task 2 is the one that starts first, and then immediately after, task 3 is starting on a different thread, okay? So task 2 is going to see that there's an await task 1, so it's going to start up task 1 and have that finish what it needs to do. Meanwhile, task 3 is going to say, oh, I need to wait task 2, and task 2 is still running, but it's not finished. So task 3 is just going to suspend until task 2 is finished. So now you've got the order that you need. You have task 1, task 2, and task 3 that are all happening. And it turns out this pattern is really easy to do in an actor. You just need to hold on to the previous task. And you need to make sure you wrap tasks in a cohesive way, meaning that you don't have tasks that throw mixed with tasks that don't throw, or tasks that return a value mixed with tasks that don't return a value. All of that's going to fall apart if you do that, because the tasks are strongly typed. So there's no any task. You have to just wrap a task in a task that doesn't return anything and a task that doesn't throw anything, and you have a any task. But that is a way around that problem where you don't have any queues, and it's a useful tool that I find myself reaching for a lot, because it's a very common pattern to expect a queue out of something, right?
Yeah. So I think I'm thinking old school here, so I don't think this will work. But if you had another way of making sure that things happen kind of in the order that, or I guess an older way of doing it is using an operation queue and setting the max concurrent operations to 1. So is operation queue, is that the right, is that the right thing? Operation queues, operations, and has that been updated to use async await, or is it? No? Okay. All right.
Yeah, it's still completely based on GCD, and that makes sense because it's a library provided by the system. And it's not necessarily something provided by the language itself.
Sure. Yeah.
But it mirrors the Swift concurrency system a lot more than the GCD base library does, because GCD doesn't really have that concept of dependencies. You can do it. It's just going to be a whole lot of work to not shoot yourself in the foot. Whereas Swift concurrency kind of has that by default, but then doesn't have queues, so you have to do extra work for queues. Sure. Which is a bit of a shame. I myself made a helper called task.serial that could it basically works like task, except it will have a global lock on a global resource that is the previous task. So that means that you can go ahead and just in your UI code have a bunch of task.serial, task.serial, task.serial. and each one will wait for the previous one to finish. Now, this has some separate problems, namely, if any one of those tasks takes a long time, it's going to hold back all the others because it's now a queue.
Serial.
So, like that's something that you do need to think about. So you might not want to use that very sledgehammery approach and make something more tailor made where you make sure that the heavy work is sent to a quote unquote queue that just like listens for the previous task. But the lighter workloads don't necessarily wait on that. So that's all dispatched separately. And that's a good way around that limitation. Then you don't have to necessarily have everything be queued behind it. You can have some asynchronous bits and some synchronous bits, if that makes sense.
Yeah. My next comment was going to be, I'm sure someone's going to make something to make that easier so you don't have to track it. And that someone was you. So that's great. Makes total sense. I was just thinking, like, kind of seems like a little bit of a pain to like have to keep track of those between tasks. So yeah, I'm sure you thought that too, and you've solved it already.
Yeah, and turns out I solved it in a slightly broken way because it turns out using unfair locks in Swift is not obvious, and I only realized that once I like shared my solution. So I did get help to kind of make that better. So I'll share a link in our show notes with the final version of this on the Swift forums, so that way you can learn about it. That is one sledgehammer approach to getting that kind of system going. Though if you have an actor, it's much simpler. You don't have to have the locks, and you can have a much more contained queue that is specific to that actor to make sure that things go in order when they need to. Mm-hmm.
Yeah, concurrency, man, it's just like...
Just when you think it's simple, it gets you once again.
It's so hard, man. It's crazy hard. It's, looking at like GCD and stuff, I'm like, yeah, that's a pretty good system. And then like async await comes around, I'm like, this is a really good system. But then, like we just talked about, async await has some trade-offs, and so does GCD. So even if, I don't know when GCD came out, in 90s, 80s or something, but it's been at least...
It's much newer than that, yeah.
Oh, is it? Oh, okay.
Yeah. A year or two before the iPhone or something.
Okay, so it's at least 10 years old, though.
Might be after.
I don't know. It's like 10, we'll say it's 10 years old. Mm-hmm. I'm sure that people have learned a lot, and, I think overall async await is a much better approach to concurrency, at least from a implementation coding standpoint. But, man, it's getting concurrency right in everything is so tricky. But, yeah, it's interesting that you mentioned the whole thing with like server-side Swift only using one CPU and stuff, and that seems to be the case for most of the time. But just looking at, I've said this before, but looking at my Vapor code before async await and now, it's like it's so much more enjoyable to write concurrent code because that's everything. Literally everything I'm writing is concurrent, just by nature of it being server-side. It's awesome. I love that we're kind of at this point. It makes it much, much more friendly to dive into and use ultimately.
Yeah, and as long as you are not necessarily starting your own tasks, like everything is going to run in order. And that's the nice thing about async await is it guarantees that. So it's only once you start like making parallel work streams that you need to think about this. And make sure that they are happening in an order that you expect, especially when you are dispatching them from a synchronous work stream, right, which is typically from the UI.
Sure.
Some real-time feedback, our follow-up. GCD came out in 2009, so it's 2 years after the iPhone, so it's very, very new.
Okay.
Yeah, and good riddance because it had a whole bunch of problems that everyone kind of... No, I say that with love because I did use and love GCD for a very, really long time, but its patterns encouraged like bad practices, namely using queues as locks. Although it is much nicer code, it's a poor locking mechanism, like things like that. And turns out the locks still are poor locking poor code expression. Like that did not change, but using actors is a much better locking mechanism than using GCD.
And it was, I mean, I can't exactly remember off the top of my head, but I remember learning like it was fairly easy to deadlock yourself by syncing and asyncing in the right, in
Oh
the
yeah.
correct but wrong pattern, right? So there were dragons.
Yeah, and I'm not saying you can't deadlock yourself with
Sure.
like Swift concurrency. Like I'm sure you can make a cyclical task like dependency,
Oh, that'd
and
be
you can really
interesting.
try hard to mess with the system, especially once you start using continuations and stuff like that. But I think the goal is, unless you are using continuations and unless you are using locks, it's very, very hard to kind of get in the situation where you are kind of messing up.
Sure.
And therefore, all you have to deal with are bugs and not crashes, which tend to be better, but are not always the best.
Yeah.
So going down my list of Mary Gotchas, we have async stream, and async stream is actually a good way of having a serial like dispatch mechanism. You can add to a stream, and the work items that you add will be added like one after another.
Okay.
That said, there's no guarantee that the things in a stream will how best to say this. So the work in a stream is processed like in order, like the return values, but the work itself is not guaranteed to be processed synchronously, if that makes any sense. Like it's a little confusing.
Are you saying, maybe I've got it backwards? Are you saying they're not guaranteed to finish in the same order, but they'll start in the right order, or the opposite?
So I think it's, and again, this is where I get confused to tell you how useful tools these are. I think it will start and finish in the right order. So if you were to loop on an async stream, you are going to get things in the order that they were added, especially the results. However, I don't know if it guarantees the actual execution to happen in the same order, much like a task group can like run things all asynchronously and all in parallel. I don't believe it will run things in parallel, but it potentially could, and that's like my asterisk when you are using async stream. So in absence of good documentation with what it's actually doing, and what I mean by that is, for all of this, you basically have to read the original pitches. Like that's the only kind of documentation that you have. The best thing that you can do is perhaps fall back to a system that makes more sense to you. So that's why I suggested the previous one, where you can just await on a previous task, and that will kind of do what you need it to do. But realize that that is not like a foolproof solution in all regards. Like there are other ways that that's going to fall apart that I will introduce soon. So it's really interesting, because although Swift concurrency tries to make things simpler, it does by extension make things more complex, because there are a lot of unknowns from the developer with this promise of simpler, right?
Yeah, it's I can't remember who said it. Someone at work, I think, but they were saying, and I think it's been echoed many times with like Swift UI. It's like it's simpler, but it's also obfuscated, so it's harder in a way. And I think this is probably a similar thing. Where
Simpler but harder because it's obfuscated is a great way of like summarizing this. Like one such way that async streams can got him is an async stream is an async sequence, and async sequences have like a hard requirement that there's only one caller at a time, meaning that you cannot just assume an async sequence is an array that has all its resources that you can go ahead and consume twice. You can only really consume these things once, and the compiler doesn't really do much to help you like not make that mistake. So that's down to you to like use carefully, and make sure you don't mess up. And something to always think about whenever you are using an async stream or an async sequence, is to never call them twice, basically. Always assume you can only consume them once, unless the documentation explicitly says, hey, this sequence is totally safe to use twice, and therefore you are good to go.
Gotcha. Yeah, lots of, like, I mean, the amount of stuff that I've done with async await has been, I think, a fair amount, but it's also, I know that it's been very like surface level. And so getting into like async streams or any of these kind of more in-depth things, like, still a little scary to me, where it took me a while to get into async await at all, but now getting into these things is like, there definitely be dragons still, even though I think probably less so, but little scary for sure, talking about, you know, these pernicious things that you need to think about. But I suppose that's how it is with everything. I don't know.
Yeah, I mean, one really nice thing about async sequences is they're very composable. So you can easily write wrappers to do different things. Like, for instance, the standard library provides some ways of reading lines from URLs, so either bytes or lines. The lines is just a composed sequence from the bytes sequence. So bytes gives you 1 byte at a time. And lines will just accumulate those bytes until you hit a new line, and then give you back that result as a string. And then wait again until it hits another new line and give you back that as a string. You can write your own that chunks data, so that way you get data that's given like one batch at a time until you run out, basically. Like every 124 characters give me a batch, a chunk, which is very useful whenever you're writing like things like multi-part data that is based on chunks.
Sure.
Like that is just like a great way of doing that. Another thing that you can do is you can transform the data as it's coming in into objects and just release those objects once at a time. And that's what my library does. I forget what I called it. Async reader sequence, I think. Yeah, and it uses bytes. So combined with bytes, you can go ahead and read like the bytes that you need, and then go ahead and transform that into an object that you can then return. So you can read an amorphous set of bytes, like one at a time, basically. And then once you have your object, you return that object, and then it will just loop and do that whole process again. So that's a great way of consuming that data as well. So there is a lot that you can do with async sequences. And Apple provides async algorithms, which is a way of using these sequences as event streams, much like Combine does. So you can go ahead and have things debounce, you can accumulate, you can match up, and do all sorts of other things with sequences, just with the giant caveat that you can only consume sequences once. Sure. So they represent a never-ending stream. Like it very much is an infinite loop that can one day finish if it wants to. So it's a very good event tap. But if someone asks for a new one because you want it in a different part of the app, you need to make a brand new one. And you need to make sure whatever you're making it from can be consumed a second time, which is where the major like downside of these sequences is that there's no like great compiler way of like warning you whenever you try to do it twice. And I think this will come eventually with the move-only types in Swift, which can let the compiler like guarantee that there's only one thing accessing a resource at once, and that should fix these sorts of things. But yeah, it's for now you have to be careful as a developer, but they are really cool nonetheless. And so since async sequences have so many downsides, you might be wondering, well, like, let's just do what Dimitri said. Just use those tasks and not need to care about stuff. So let me tell you why that's a bad idea too. because everything is a bad idea in the end. Maybe Swift concurrency was a bad idea. I don't know. I think it was a great idea. I love it, especially for Vapor. It's super neat to use in that context. But if you're in a non super concurrent context to begin with, you're going to find yourself making tasks a lot.
Sure.
And you might want to make your own task. Like you have a task that needs to download an image from the server, download the key to decrypt that image, and then once you have both of those things, marry them together and actually decrypt the data, right? That might be a common task. Or maybe you have a task that will download some JSON from the server, and then that will have 17 images in it that you want more or less as they come in. So then you want to, in parallel, download all 17 of those images and then make a collage out of them, right? That's another thing you might want to do, where you might be in a concurrent context, but you still want to start subtasks, right? Now, there is an easy way of starting subtasks, and that's with async let. And async let lets you call into an asynchronous method and then not necessarily wait on it, meaning you can go ahead and let it start and then await on it later once you started all the other things that you wanted to start. And what you're given back is a future. And I say future with air quotes here because it's not really a future from your point of view. It behaves like a future from the runtime's point of view, but from your point of view, it's just the value that you need. You just need to wait it when you want to use it. So that's the only difference there. But from a runtime point of view, it very much is a future. And what I mean by future, this is a type that is a placeholder for the real data. But if you want to actually access the real data, you need to suspend and wait for it to become available. Otherwise, you just can't use it. So that's where those child tasks kind of fall apart. And they don't necessarily fall apart in that way, but you do need to have a handler if you want to await on them at all. Like you can start them and then just ignore them. Like this is any task that needs to like write to disk. You don't really need to care if it succeeds or not, because most of the time it will succeed. Like, of course, maybe you want to care and present an error or log it or do something somewhere. But child tasks can have some other benefits in that they will cancel automatically if the main task gets canceled. And they will do all of that for you. This is different from when you make a task with task open curly brace. That is not a child task. That's a top level task. Sure. However, it's different than task.detached, which is the third type of task, in that it will carry over the priority and the calling context from the parent that it's in. So what I mean by that, if you said that a task is a user-initiated task, meaning it's high priority, the subtask that you call when you say capital T task open curly brace, that will use that same priority. In addition, it will use the same actor that you're currently in to use whenever you're calling other things. So you'll have noticed in your actor itself, you didn't necessarily need to use await everywhere for the actor bits, because the actor is a context in itself, right? And that is made simple because tasks will kind of remember that calling context. However, task.detached will just straight off the bat say, hey, I want to be started on a background thread and just like do me as fast as possible. Like you can set a different priority, of course, if there's a queue of tasks that need to run. That can happen sooner or later as a result of that. But this is a way of you saying that you don't care what the calling context is. You just want it to happen completely asynchronously to what's currently happening. Order be damned in a way.
I might have missed this, but then when you have a task group and you say like group to add task, is that a top level one or is that a detached one or something different?
So task groups are child tasks, and they do this by making the child task themselves. And I will explain quickly how this happens. So child tasks are that very special type where you have async let, right? You have async let, a new variable equals some concurrent work that needs to happen for that variable to exist. So that's what a child task is. And a child task is different from task with a capital T in that if the parent task gets canceled, the child task will also get canceled. So that's the key difference between those two types of tasks. Now, child tasks do this automatically via the compiler. Task groups are a way of simulating this by like saying, hey, I want to have a bunch of child tasks, essentially. They all return the same thing. It's going to end up giving me an array. It's just going to execute all at once. And then that array is actually a async sequence that you can go ahead and consume in order. But like even if things later down the line finish first, like you're not going to go and jump to that. You're going to wait for everything to happen in order in that for loop, and that's going to make things simpler on you. Now it makes these child tasks by having a task cancellation handler. So this is a very fancy thing that instead of allowing you to just check, hey, did the task get canceled, you can listen for task cancellation. So this takes two things. It takes an asynchronous context that it's going to run, and then it has a non-asynchronous callback that will be called when a task gets canceled. And this non-asynchronous callback can be used to cancel anything you want. So, for instance, if you want to make a new task with a capital T, a new top-level task, then that will give you a handler of its result, right? That you can then cancel in the future. So if you save that handler, you can go ahead and cancel it in with task cancellation handler, and that will allow you to cancel your top-level task as if it were a child task. Does that make sense?
Yeah, I think I follow.
So
I think I follow enough.
It's a roundabout way of making child tasks programmatically, basically.
Sure.
When the only way that you could otherwise make them is with async lets. And ironically enough, every time I've thought I've needed a child task, I ended up not like using it in the end. I always rewrote it as like a synchronous operation, just because a lot of times it makes a lot more sense for things to happen one after another, even if they could potentially be concurrent. So always keep that in mind, that concurrency is often not what you need unless you really know you need it, at which point you might want to just use task group, because that's going to be the batch like concurrent method of like running a whole bunch of things at once, and not just like one or two. Like async let is when you have like two things that are well defined that you need to run at the same time, but generally that's not the case, right? Generally you have like 50 things that you need to run at the same time, not one or two. So that's where task group comes in.
I'm interested to see. I haven't looked either, but I'm sure there will be some good books written on async await by the likes of, Paul Hudson or like Obfusc.io or something. I love like the Obfusc.io books because they go into some really good detail. Like on like I was saying with Swift UI, it's like pretty magical, and it just kind of like automatically, it's a little hand wavy and it works. But they go into depth on like how does like the view tree work, and how is it that you can swap views and have it be so efficient and stuff. So if there was something like that with async await to really, maybe I just need to read the Swift proposals. I don't know. I want an easy way out of just like write a book for me and do the hard work and put it all in one place. So
yeah,
there's
I think they already have a bunch of articles for
do
it.
They?
Yeah,
oh, cool.
Especially sequences I found myself referring to as well. So they did a lot of that work, so there's likely a book incoming.
Sweet.
So Apple supporting the economy by not writing documentation.
It's like, it's kind of good, but also first-party documentation would be good too.
It's like, come on, Apple.
Yeah.
It's great that you're supporting the economy, but documentation, come on.
Yeah. DDD, guys, come on.
Yep. So yeah, needless to say, there's like a lot of gotchas with Swift concurrency that you need to like keep in mind as you start using it for more and more advanced use cases, but I do want to say you'll likely learn about these as you're using it, so don't let these like scare you away from like using Swift concurrency. It is way better than GCD. It's just there are a different set of trade-offs, especially if you're coming from GCD and you like have it ingrained in your skull that like queues are a thing, and it's like of course they would be a thing in Swift concurrency. Why wouldn't they be, right? Like, come on, Apple. Same author of these two things, like you just expect it to happen. But yeah, they are not the same. They have different trade-offs. They solve for different needs. And I do think Swift concurrency is like headed in a much better direction, considering that in Swift 6, the compiler will be able to tell you, hey, your asynchronous code is really borked. And that's like something that you'll probably want to fix before actually compiling this. Like, we're not going to let you just even run it. It's borked.
I won't
it's not going to work.
It's that bad.
So yeah, Swift concurrency. It's great, but there's it's not GCD, and don't mistake it for it. And you'll have a much better time. And it'll only get better with time as the compiler continues to improve. There are already a bunch of options that you can set like as warnings that can let the compiler tell you, hey, you're shooting yourself in the foot right here, and this will be an error in the future. So you might as well fix it now. So looking forward to all of those.
I remembered. Like Swift UI, they've made it nice because it's like pretty intercompatible with GCD, so you can kind of put it in at your own leisure. It's something at work we we have a, I think, monthly meeting about just internal improvements and stuff, and just talking about more developer-y things instead of getting with the entire team. Our team's not very big in general, the entire company, so a lot of meetings we just have with everyone. But we've talked about, wherever it makes sense and wherever it's not like a potentially hugely breaking thing, try to throw an async away or Swift UI as well. So you can kind of put things in at your own leisure, make sure they work okay, and you don't have to it's not like a Swift 2 to 3 conversion where it's like you have to change everything at once. It's like, do it a little bit at a time, and that's okay. So
yeah,
maybe challenge yourself to throw in a task or two with some async await code if you can. Not you, but the listeners.
Yeah. And as I mentioned, like Swift UI makes this really easy to get started. Like instead of on appear and on disappear, just .task. And then you're in an asynchronous context. You can go ahead and start a task. And if your view is thrown off screen, it gets canceled. Like that's the super neat thing about it. So it allows you to use a big part of it just right then and there. And anywhere else, you can just start a task, capital T task, open curly brace, and then do your asynchronous work. Just keep in mind that don't try to use this with like delegates and other UI kit stuff. Make sure that it's like very asynchronous work streams that are going into this. And if you do want to use it with delegates and stuff like that, you can definitely use like my helper task.serial to do that, which like takes care of like making sure you have a lock before you start queuing up things from the main thread. So definitely give that a look. It makes incremental additions of Swift concurrency. Yeah, not Swift UI. Swift concurrency easy in your UI. That was a lot harder to say than I thought.
Yeah, you're good. I got you.
So this week's episode of Code Completion is brought to you by Pennant. Calling all sports fans. Want to keep track of the season, but there's so many teams and not enough time? Check out Pennant. Pennant provides sports standings at a glance. Pennant displays league standings as a simple bar chart where the best teams rise to the top throughout the season. Of course, you can dig in deeper with team stats, game results, and more. Version 10 introduced the all-new customizable My Pennant view, which you can build a wide selection of visualizations for any sport, division, or team. Unlock Pennant Premium to add as many blocks as you'd like and put any of them on your home screen as a widget. Whether you follow MLB, NFL, NBA, NHL, or MLS, Pennant has you covered with more sports and leagues coming soon. Thank you so much to Pennant for sponsoring Code Completion. Download Pennant on the iOS App Store today. So, I've had CarPlay on my car for the past few years, and it's been great. I really like it. It's nice having a car that just continuously feels new in terms of its UI.
That's true.
And this is like expanded by my wife's car, Lynn. She has a Toyota from 2014, I think. And that one does not have CarPlay and has a really teensy tiny display, which is funny coming from 2014. But that has not been improving, and it stands in like wild contrast. And it really does make the car continue to feel new, as like parts of it don't feel like they're just aging under you, and they are improving over time. That said, I've gotten tremendously jealous of the newer versions of CarPlay that have been added to vehicles, that admittedly have not been added to most vehicles because car manufacturers. But you can have wireless CarPlay, which is a mythical experience that just works, where you can go ahead and walk up to your car, turn it on, and your screen is nice and up to date with your phone. And I was like, I want that, but I'm not going to trade out my entire car for that. Not to mention, I don't think I'm not entirely sure Honda's like on board the wireless CarPlay train yet, which is interesting. And it's especially funny because my car has Wi-Fi, like for no reason. You can't even update weird. Anything. It has Wi-Fi though. You can browse the web. I found that very broken, but it exists.
Yeah.
Like there's a whole like Android OS thing running to run the CarPlay. So yeah, that's a thing. Yeah, so I wanted to try wireless CarPlay. And I was promised that by the internet, of course, that this was a very straightforward thing if you wanted to do it. And that was made possible by this neat little dongle called CarlinKit. This thing looks ginormous on Amazon, by the way. Like if you go ahead and search for it, it looks like it's going to be this ginormous box, like a hard drive from the 2010s. Sure. But it's this little tiny SSD sized dongle. Another silly reference to hard drives. I don't think there's an SSD in here. But it's a little tiny, like, I don't know, I'm gonna guess Android. Yeah, little thing that's running on the inside, and it plugs into your car, and it simulates a CarPlay screen. So your car thinks it's getting a screen from CarPlay, except it's not getting a screen from CarPlay, it's getting a screen from this little thing. And this little thing invites you, say, hey, go to your phone, find the wireless, the CarPlay section, and choose this wireless thing, and enter this code that's showing you on the display. And once you do that, from that point forward, this will go ahead and receive a CarPlay connection from your phone, which is just an H.264 stream, as far as I know. Like it's the stream of video and then the touch events going back the other way. So it gets the stream of video from your phone, wirelessly using the same wireless CarPlay that your phone would otherwise use on a wireless CarPlay car. And it will go ahead and turn that into wired CarPlay over the USB to your car itself. And that wired CarPlay will go ahead and transmit your touches back to the phone. And this works surprisingly nicely. So I just need to go into my car, turn it on, wait for that warning screen that says you cannot use this while driving. That has a continue button that doesn't do anything until a few seconds, like a very typical mandated government warning kind of thing. And then once that button goes away, depending actually, if I tap that button, I do see the little CarPlay interface from this, which is not CarPlay, it's just like some custom UI that they have that says like waiting for connection. But if I ignore that continue button and I just let it go away on its own, which it typically does, by that point in time, my phone has had a chance to connect to it, and everything is just hooked up. So I, who have gotten very used to plugging my phone in every time I sat in the car, no longer need to do that. I just kind of sit and turn the car on and everything just kind of comes alive. And that is really, really, really cool. It feels like Bluetooth all over again, except with fancy screens and stuff.
Yeah. Yeah, I was going to say that my car is almost as old as I am. And so I am not I don't have that luxury of even having wired CarPlay, but I previously, when I first got my car, I put in it's like a '97 Civic, so it's like super old. But I put in a different stereo in it so I could plug in my phone, my iPhone 4S or my iPhone 4 or whatever.
You didn't want to get one of those cassette
No, I mean I could. Yeah, the cassette aux
streams
things. Those are cool. Those are like so cool and mind blowing. But no,
What a solution to a problem, right?
I spent $100 and got that, and it was cool. But then couple, I don't know, 4 or 5 years ago, I got just another stereo, but it has Bluetooth. And like you said, it's like Bluetooth all over again. That's what I have right now. And it's like going from just wired to Bluetooth is so nice, not being, leaving your phone in your pocket and it just connecting and starting to play music and stuff. So that's super cool. I was going to mention, in my quest for CarPlay in my car, thanks Apple, for not letting me have that on an iPad. I bought like a super cheap Amazon Fire tablet one time because that can run. There's an Android Auto app, and then you use that same CarlinKit thing with that. And I don't know. I tried to make it work. It didn't work very well, but I'm glad that it's working for you. And I messaged Dimitri when he sent a link to that CarlinKit thing. I was like super interested to see how it worked because it didn't work for me at all. But I was using it in like a super janky way with an Android tablet, so I wasn't quite surprised that it didn't work for me either. So
yeah, so one downside to this CarlinKit thing, one, the name is kind of hard to say if you like use their approved capitalization methods. Is CarlinKit.
CarlinKit,
yeah, not great. But there are like a million versions of this on Amazon, so like buyer beware. This is going to be confusing. Let me lay it down for you. So there's CarlinKit 1 and CarlinKit 2. Those are old. Ignore them. Now there's CarlinKit 3. There's like a big one. This is the big one. Little tiny thing. Okay. And then there's a mini one. I don't know what the mini one is, but this is mini enough for me. Just saying. So I went with the big one. And you might be confused. Like, why did you get CarlinKit 3 when there's a CarlinKit 4? And CarlinKit 4 takes CarlinKit 3 and adds Android Auto support. And I'm like, I don't want an extra thing that I'm never going to use. So I'm going to just stick to the CarPlay only version, which is probably like all I'll ever need. So yeah, CarlinKit 4 has Android Auto like support in addition to CarPlay support. And that sounds to me like an extra opportunity for things to go wrong. So I'm like, I decided to stick to the CarlinKit 3 thing, which apparently has much better like latency. I have not noticed any additional latency over the wired version. Like there is some latency just from the car's version of CarPlay, so that exists, and that I'm okay with. It's not the end of the world. Like you can't pinch the zoom very reliably. Oh well. But the actual like usage of it, like no different than the wired version, so I'm happy with it. Now there is one more thing that they have is CarlinKit AI. And CarlinKit AI uses the magic of non-existent AI to give you a full Android Auto like puck that lives on this thing itself. So you don't have to have an Android device. And this full Android Auto puck is advertised to have full access to YouTube and internet browsing and all sorts of things that I do not need. And that is a thing. It would technically be illegal, and I am not interested in. So, I don't want to be watching videos while driving. That's like dangerous enough as is. Like driving is dangerous enough as is. No need for additional distractions. So I did not opt for that version either. So yeah, CarlinKit 3.0, nice little puck thing. Great. Now, one downside of my new wireless escapades is I now no longer have a way of charging my phone in that process of using it. So this thing does have a pass-through USB, which does pass through CarPlay and charges your device at the same time, which is neat. But my car, it's a Honda Civic 2017, and part of one of the accessories you could buy is a Qi charging pad for right above the little shifter. And this Qi charging pad that Honda sells is like $200 something, and I'm like, no, it's like Qi charging 1, like the very slowest version. So I like did a little research, and it turns out there's a company called CarChiWireless.com. CarChiWireless.com, right there. So this is it's just a like piece of plastic that you can put right in that little tray. It fits perfectly. It's molded to like that exact model, and they have models for like everything under the sun. Like if I were to make a lot of noise, you can see here like they have a version for like almost every car in existence that can charge via USB, or like I guess the little what are those called? Cigarette lighters. That's what it's called. And it fits right there, and you plug it into the cigarette lighter, and yeah, that seems like it would work great. Now, small minor problem with that. I read online through Amazon reviews that you can get faster charging if you use a faster like power delivery little cigarette lighter thing. Is there a better word for those things other than cigarette lighters?
That's what I would call it.
Yeah, the most I've done with that is burn through car seats accidentally, playing with fire, and not lit a cigarette with them. So, like, it feels wrong to call them cigarette lighters in my head. But, yeah, so, what was I getting at? Oh, so I got one from Anchor that does, like, 30 or 5 watts or something, and I'm like, I can power a laptop with this. This is cool. So, it has 2 ports, one power delivery USB-C and one regular USB-A, and so I plugged this thing into the USB-A one, and there is one issue with that like whole system, is that if the car is started and I place my phone on the pad, it doesn't seem to charge, and it will only charge if the phone is on the pad before I turn the car on.
Oh, that's way weird.
Yeah, so I don't know if it's that little dongle or not. It might be the one that just like made a ton of noise on the floor over there that I need to use, and maybe then it works consistently. I still need to test. I got this thing like a day ago, so I'm not gonna necessarily like yell angry reviews at the poor, what are these people called again? CarChiWireless.com people. Like what they made is very nice. It fits perfectly. There's probably I'm using the wrong like spec of USB non-spec power delivery things. So I'm gonna try with their like inbox little puck thing, cigarette lighter that does not have 2 USB cables. So that's like the one downside. But yeah, I'm gonna give that a try, and then I guess I'll report back to see if that works any better. But if the downside is me needing to put my phone there before like starting the car, then so be it, I guess. I don't know why that's like, it's such a weird bug, right?
That's like super weird.
It does charge, and it charges seemingly enough to like increase the battery of the phone over time rather than decrease it. So that's good.
If anything, I was gonna say like it would be maybe it didn't charge if it started with it on the. Like, your phone was there, and then you turn on the car, and it didn't charge then. You'd have to take it off and put it back on or something, but that's weird.
Yeah, that would be more annoying. But I guess I'm not supposed to be touching my phone anyway, so there's, like, no reason why it would move. Like, the thing is grippy, so, like, it stays in place, which is nice. I haven't driven like a lunatic to see if it would dislodge yet, but we will see one day when I decide to risk my life for mini review corner. That will come up. It's like, oh yes, it flew in the face of my passenger as I took a sharp right turn and screeched tires. So yeah, that didn't happen yet. So I don't know like how grippy. It's grippy enough for regular driving, which is what I care about. And like the space is confined. Like where's the phone gonna go? So I think it's better than my previous solution where I had a lightning cable that was snaking through like the console thing to the USB port around the shifter and then down into the cup holder, which like I had plenty of mobility in my shifter, and I'm not going to be hindered by the phone cable or something. But that was like not great, because then anytime like my wife needed to reach my phone, it's like she now needs to reach over me while I'm shifting, which is not obvious, not the best. So it's a much better cord-free future that I live in. But like sometimes I guess it won't charge, which I guess will suck the most over a 2-hour long car drive when you find out at the end of it nothing was charging and your phone is dead and there's no way to get it back via the wireless version, and then need to figure out some wired version and then be in the same can of worms that you were in before. Yay.
Yeah. I was going to say, great, they have pass-through, so it's like that CarlinKit thing doesn't even do anything. You're just passing through and having the exact same situation you started with.
So it's actually a separate like device from your phone's point of view, whether it's wireless or not, which I found interesting. Like I plugged it in via cable first to like register. I was like, oh, this works. And then I unplugged it and like wireless did not work, and I had to redo it for wireless. Like I would have assumed it could like magically pair or something. So yeah, I don't know if it needs to like. I should try that now to see if like me plugging it in is now the same device as the wireless version from my phone's point of view. That would be.
You'd think so.
Mm-hmm. So yeah, that's the CarlinKit 3.0. If you have a car that supports CarPlay, once again, this will not work unless your car supports CarPlay. This will not work unless your car supports CarPlay. Do give it a try. I think it works quite nicely. So as always, I want to personally thank everyone for listening in this week. Please be sure to follow us on Twitter at CodeCompletion to know when we go live, because I don't seem to tweet when we release episodes, but I do tweet when we go live. So do follow us on Twitter if you want to catch us when we're recording. And watch it happen and the disaster unfold. Yes. And if there's ever a topic you'd like for us to dig into, feel free to tweet at us those as well, because that helps us a lot as we continuously flail around trying to think of topics to talk about. So most importantly, as a small podcast,
we're totally organized 100% all the time. We've got a huge backlog.
Look at this wonderful script I have that we like. We're on top of things, at least on an episode by episode basis. In between episodes, we flail a lot. So yeah, as a small podcast that flails a lot, please be sure to share this with your friends and family who are also interested in any part of the process of app development. It's your support that enables us to continue doing this, and we hope to grow a healthy community around everything we discuss. Once again, I want to give my thanks to Spencer, who is at Spencer C. Curtis. That's SpencerCurtis on Twitter for joining me this week. My name once again is Dimitri. You can find me at Dimitri Buniol. That's DimitRiBounIOL, and we'll see you all next week. Bye.
Bye.
So I have a mini rant commented out.
Oh, awesome.
Awesome. The perfect one. So I have a second thing that I could potentially have on a mini review corner, and that is the wonderful AC that I don't know if you can see from this vantage, but I installed a mini split over the past many weeks. Yes. And this makes this room wonderful. It has been an absolute okay, let's first talk about mini splits because they are amazing. It's a split system. So if you have ever kind of looked into how an AC works, you have something that compresses gas and then decompresses it. And when it decompresses, it cools down tremendously. It's like if you ever get a can of compressed air and you use it a lot, the whole can gets frigid, right?
Yep.
And that's because the gas is decompressing and that makes things cold. So it's using the laws of something to make things nice and chilly. And ACs abuse this fact by putting a fan in front of the cold thing and saying, here's magic cold stuff. The problem with the conservation of laws of thermodynamics, which is not the name of the conservation, but it's what I'm going with because I did not graduate in physics. I failed that. And this is what I know, and this is what I'm sharing today. Man. So because of these conservation things, because of these conservative gases, on the other end... On the other end of this spectrum, you have a compressor, which is compressing gas. And when you compress gas, it gets very hot, right. Which is the opposite of the cooling down effect. So global warming is actually caused by ACs worldwide blowing hot air out of the house, because that's what it's doing. It's exchanging the hot air that's inside and making it cool, and then expelling the hot air out and causing global warming. Just kidding. That's not what global warming is caused by. It's just fun facts that ACs make the outside air hotter, and are insignificant in the grand scheme of things, because it's the electricity that you're using that is causing the global warming, not the ACs. So if we were to 100% switch to renewable energy that does not use fossil fuels, that releases CO2 into the atmosphere, then this minuscule amount of heating from ACs is not going to really do anything. So I want to put that out there before anyone takes my joke as serious. But, okay, so going back to a mini split. A mini split is a split system. So you have the compressor on the outside of the house. You have a bunch of tubes of copper that go inside the house, and one will contain essentially compressed fluid of gas, Freon usually, and that will decompress inside the coils on the inside of the house, which will have a nice little fan that will blow it and circulate it. And then you can usually tell if there's a mini split if there's like this big hunkin' piece of plastic that's just sitting on a wall, and that's the whole AC. You don't hear anything. It's just a quiet fan that's just like circulating the air, and it will tell a unit outside to just like, hey, start compressing. And that's the thing that uses all the energy. It's not the little fan. So one thing that I noticed, we have a full house AC that like is major electron guzzler. It will, like, if we have it on all day, it will easily consume 50 kilowatts and more, depending on how hot it is. So yeah, don't necessarily want to run that all the time, because most of the house is cool, actually. Like, weirdly enough, it's very well insulated, so we can survive 95-degree weather outside, and it will be, I don't know, 82 inside, which is relatively fresh, and we don't necessarily need to use the AC, so we can save a ton of electricity for that. However, this room in particular has lots of computers, and lots of computers that are on for the most part because they are acting as like a file server and stuff like that. And that generates a lot of heat, which means that this room in particular, being on the side of the house that receives the most sun, gets very, very hot, and is oftentimes 10 to 15 degrees hotter than the rest of the house. So I don't want to run the whole house AC. I want to run a nice little mini split. So this nice little mini split, turns out, is very, very quiet. So we have that whole house AC, as I was mentioning. That's like a big box that sits on a roof. That shakes like one of the other rooms to like no end. Like, you can hear when this thing is on. It's not a mystery to anyone. Meanwhile, we cannot tell if the mini split thing was on the outside. All we could tell is hot air was blowing out of it. Like, you can see the fan spinning. You cannot hear the compressor, however. So that was like a mind-blowing thing. I thought this thing would vibrate to no end on the outside. I was like, let's put it a little farther from my room so I can have the AC on and record at the same time, which is never an experience that I've ever had. I've always like, let's turn off the AC before recording, because that thing was loud. So now we have this nice little thing. It's very quiet. It works tremendously well. Now comes the problem. So I ordered this thing because on Home Depot, if you search for HomeKit mini split, this thing is the only thing that shows up, and it says has support for HomeKit, Siri, and all these things. That is great. So I installed it, and I was very wonderfully surprised to learn that apparently these people don't know what HomeKit is, and not even sure they know what Siri is, because it has an app that you can use to control whether it's on or off, and that's great. But that app is not HomeKit. I have to remind everyone that HomeKit is a specific thing, and this thing failed to deliver on that promise. So although I am more or less happy, I did want to like use HomeKit because I have a bunch of sensors throughout the house. I can automate certain things, and this thing has internal automations that are based on like weather data outside. That is not useful to me because I don't care about the weather outside. I care about the temperature inside near my computers, and I wanted to use that as the signal to turn it on and off, so that way I don't have to have it on all the time. So yeah, that's a thing that I feel backstabbed by for the minorest things. Like, I am very happy with the AC itself. It is working fantastically. and that is great. However, like, yeah, not cool to promise one thing and not at all deliver. Yeah.
Yeah. I Dimitri mentioned this a couple of, or kind of talked about this, I don't know, a week ago or so, and I've been thinking about it, and I realized that my garage door opener, the thing that opens my garage, I don't know, the whatever, it's like internet connected, and there's an app for it, but it's not HomeKit enabled or anything. But there's something you could look into, which made it so that my garage door could be opened through HomeKit, is called HomeBridge. And you've probably already looked into it, but that's something that you could do to see if there's like a HomeBridge plugin to, if there's an app for it, maybe there's API that, that could kind of be the literal bridge between that and HomeKit to make it HomeKitified, even though they lied to you. So
yeah. So HomeBridge you can run on any computer, or does it have to be on like a Raspberry Pi or something?
I don't know about on a Mac. I run it on my. You could definitely run it on a Raspberry Pi, and if you don't have one, I can send one to you. But let's see, because
are Raspberry Pis under like short supply?
They're so expensive right now; it's ridiculous. They're selling for like
because of the chip shortage, right?
Yeah, they're selling for well over what they should be. Oh no, it looks like you can run it on macOS or in a Docker container on macOS.
Sweet. So I have computers that are heated, internally heatings that are going to run a system that are going to cool them down, and hopefully nothing will go wrong.
That's the circle of life, baby.
If they self-melt, that's their fault.
So it's an option. I don't know. HomeBridge is supported for a lot of things to make it so that non-HomeKit stuff can be HomeKit stuffed, and it works really well. It honestly seems a lot more responsive than the garage door opener app, so which is, I think, hilarious. But it's an option that you could look into and maybe give us an update next week or whenever you figure it out. So
yeah, my only thing is this is like apparently a new like AC system, so I'm not sure that anyone has reverse engineered the API for it, so I will have to look into that.
Yeah. There's a pretty good community, like Reddit and stuff. I think there are a couple subreddits and stuff that you could look into for HomeBridge. So
cool. We'll give that a try.
Yeah.
I'm still waiting for them to reply. I left a nicely worded. I told Spencer I'd leave a very nasty worded email of like cheating via like false advertisement. But I left a nicely worded email of like, maybe I'm not finding it, maybe I'm dumb. And they have not gone back to me, so I'm getting close to exploding. But I can explode with everyone here, so maybe this will get it off my chest. Yes. Because all in all, I'm more or less happy with the AC. I'm just like a little pissed that they essentially lied. And I hate the fact that I likely know that they did lie rather than like, oh, maybe they did make a mistake, because there's nothing that indicates that there's any HomeKit support whatsoever.
Yeah, give them the benefit of the doubt, I guess.
Yeah, so I will wait like a week before being... like at least reply.
Look, use
reply to the email.
Use your platform of, I don't know how many followers we have, to blast them on Twitter, and that's what we do around here.
Oh, I checked. They don't have a Twitter presence. They have the CEO of the company last tweeted like 5 years ago or something.
Ooh, okay.
And that's their Twitter presence. So not useful.
Dang it.
I tried.
Almost used our very powerful platform of 468 followers for justice.
Weaponizing our platform for justice.
So.
Okay. I guess titles.
Yeah, we got plenty.
Make sure it's hunky dory. Got 'em. Everything is a bad idea. That's a given.
Yeah.
A lot of gotchas. Your concurrent code is b0rked. Weaponized car platform. I like this one, but it has nothing to do with the rest of the episode, so I'm gonna leave that aside. Your concurrent code is b0rked.
Okay. Sure. Yeah. Relevant.
Cool. Thanks for listening, everyone.
See you next week. Bye.
Do we capitalize B?
Not if it's got the O.
Darn you, title case. We need a lowercase o, 0.
Yeah, lowercase 0. That just broke me for a second. All right, see ya.
Bye.